Good morning. Oh, you know what? Does this scene actually have? It doesn't have any of the music or anything. Did I nuke that before? Huh. Now it looks like OBS actually forgot some of stuff here. I wonder why I can't see that anymore though. Testing, testing. Good morning. All right. Is the music present currently? If anybody's out there. Change tracks. Ooh, robots. Smash those robots. All right, so we got that. What else are we gonna do? We need to do this. All right, I think we're about ready. Let's get going. So, let's see. I was trying to implement stream for ARC last night, and this was just a little bit of, like, over my head. And I want to understand this better. But first, daily bad joke. There it goes. I couldn't quite remember how to throw a boomerang, but it eventually came back to me. Oh, it's so bad. So bad. Alright. What am I actually calling this library? I think Alright. What is a crate name? Alright, let's take a look at this. My mouse is just freaking out today. That's what I get for leaving it alone. Good morning. Hello, hello. So, I took a peek at actually how to implement some of this stuff last night, and it was kind of mind-bending here. I tried to implement this without the for loop. And to give reference, what are we doing? This is similar to async dupe, which lets you put a async dupe lets you put a async read and write type instead of an arc or mutags, and provides those interfaces onto those, which means that you can then toss those into things that are streamable, or I guess not streamable, but async read and writable. It's very useful for certain things. And good morning, Togglebit. How are you? Hey, Jack Zuck, thank you for the follow. So, I tried to implement this without a little 4-bit there. I tried to do it. I just duplicated it, just making sure. Yep. Let's comment this out. Because the natural way I would try to do this would be something a bit more like this. I would say just, where T was futures. That would take the item off of here. This would be T item. Get on with your day. All right. Thank you, Togglebit. And good morning, everyone. All right. I'm still warming up here. Let's do one more joke. Police were called to a daycare where a 3-year-old was resisting arrest. Resisting arrest. Didn't. Oh my goodness, that's bad. All right, so this is how I would normally try to implement this, but it's not quite right. I can not get basically the pin correct in order to call pull next on it. I'll always end up with like a double borrow or something not quite enough. So getting it just perfect, you do seem to need this lifetime here. It's too close to home. Oh man. I imagine a lot of parents are going through that recently with the whole stay at home bit. You know what? I forgot. Forgot one thing. I gotta clean up my network real quick. It'll just take a moment. There we go. Okay, so without that lifetime, we can't get this set up right. And I'm trying to understand like exactly what it does, and if I can get rid of that item down in there below. Because ideally, it'd be nice if you could just specify that the associated trait type, like you would naturally, like this T : item. But that's not possible with a for loop like that, or with a for lifetime specified. Because if we look at this, see, my mouse is just a little jumpy today. Get it? Alright, let's toss in chat in case you're interested. I'm gonna open that up too. Oh, you know what? This is a different document. Trait bounds, higher rate. No, that's the same one. Okay. It just looked different on my phone last night. Alright. Let's see. Trait and lifetime bounds provide a way for generic items to restrict which types and lifetimes are used as their parameters. Bounds can be provided on any type in a where clause. Also shorter formats for certain common cases. Alright, bounds written after declaring a generic parameter. Yeah, we've seen this before. There's also the Namicon one. Look at that in just a moment. Super traits. We looked at super traits before. This is the thing we use all the time. And the third one, that's not even it. Size, lifetime bounds. Here we go. Lifetime bounds can be applied to types or their lifetimes. All right, for example, such a bound for A, this is like what we're doing here, would require an implementation like this. Then it can be used to compare anything with basically a borrowed T with any lifetime to an I32. So why do we have to say with any lifetime on this? I get that this is generic, like we're not constraining this lifetime. We're not saying, oh, this lifetime is constrained to self. Or are we? What are we saying here? For any lifetime, basically it's a borrowed T, isn't it? Let's try to pull this apart, see if rock it a little bit better. They got it to work. I was looking at some of the code in that other project, and it's like, okay, well, if I line everything up just right, it might work, and it did. But now I want to know why. Actually, what is this saying? This is saying that we have a borrowed T? Is this saying where a borrowed T is a stream? Interesting. And is there a way to get at its associated trait types so we can update this down here? Yeah, this 4A. So the 4A here is just declaring a lifetime. It's saying for all lifetimes. And it's giving it a name. So this is a representation. It's A here. Take A. It's for all lifetimes. And it's what we need to do in order to be able to express that this thing is going to be borrowed. I mean, this could be a static lifetime. This could be some short lifetime. I don't know what it is in this case. Hey, good morning. It's an infinite list of lifetimes, so it's basically for every lifetime, right? For all lifetimes. Godot score. Happy Sunday. All right. Only a higher ranked bound can be used here as a lifetime for reference. It's shorter than the lifetime parameter on the function. For something that as the lifetime of the reference is shorter than a lifetime parameter on the function. Motivated you to do some more fun programming. Awesome. Man, I love learning. I absolutely love learning, and it feels like Rust is just a never-ending fount of opportunity to learn. I mean, not only is a language huge, right? Like, well, I say it's huge. It's just bigger than I can see the end of. It's looking at the horizon on an ocean. But then all of the awesome projects out there, all the different crates. And there are so many good ones. So many people are just fantastic at Rust. It's amazing. Higher ranked lifetimes may also be specified just before a trait, the trait. Oh, I see. Okay. Oh, can we actually put that on the right side and make this work? Probably not, because we probably want the borrowed T, doesn't it? Yeah, we want the borrowed T. Alright, let's take a peek at the Nomicon copy link address. The difference between Impel Lifetime A is that it defines the lifetime only for the bound. That lifetime has to be used in one of the constraints on that's a good question. Actually, yeah, what is the difference between having the lifetime there on the generic list versus declaring it down below? That's a good question. I'm not sure. Let's give it a go. Actually, I want to see. What if we did have a lifetime here? All right, can we take that off of this? There, and say it like that? Now it's saying that the item is not constrained by the infiltrate. Why not? I mean, it's used down here. And how does the 4A actually fix that down below? What? No way. What? And I got some like lag on my machine at the moment. Alright, hold on just a moment. I'm gonna reboot Chrome. This Chrome's not being friendly at the moment. Alright. It's not used. Alright, that might be a little bit better on my mouse. I actually use a Raspberry Pi with Synergy, so that I can share the mouse across a number of machines. So I have Synergy. This is a little dinky Pi with my keyboard and mouse input instead of it going into the USB hub, because I was suspicious. Before I would get some like repeat keys, or I get some keys stuck or something. I think it was the hub was a culprit, and I haven't had keys stuck since I put it into the Pi. It's working out really well. Now, where a clause represents an infinite list of trait bounds, because you don't say arc lifetime, which is a crucial part. Okay. So, yeah, let's get rid of that. It's just a Nomicon. Oh shoot, I lost the Nomicon reference. When I rebooted the browser. Would you mind tossing that in there again? It's interesting that it probably just worked. Hmm. So this is the lifetime of t, right? Thank you. The word clause represents an infinite list of trait bounds because you don't say arc borrowed t, which is a crucial part. I see, so because we're not saying that, it's okay. I think I saw this last night, but it is like a very, very short page. Alright, so yeah, this is talking about closures. Yeah, I read this last night. So we take this information, it's going to talk about this function here. It's f, the lifetime. Okay. We might try to naively desugar this code the same way we did in the lifetime section. We'd run into some trouble. Call a, lifetime a, etc. How on earth are we supposed to express the lifetime on f's trait bounds? We need to provide some lifetime there, but the lifetime we care about can't be named until we enter the body of call. Oh, I see. So it has to be, this is because of where it's called from. Also, that isn't some fixed lifetime. Call works with any lifetime self happens to have at that point. I see. So instead of it being a very kind of static and constrained lifetime, it really is any lifetime that happens to have at the point of it being invoked. For all choices of A, yeah, basically an infinite list of bounds that must satisfy. Wow. I see. So it really has to do how it's being called. And this I get. Okay. What do we call this? Async arc stream. We're going to use this in this other project. Okay. Down here, we're back in the stream multiplexer. Okay, this is lib.rs. This is the receive function. Now, what we have here is at the very top, we have channel. We're getting the value of channel. Because channels here is now a dash map. Yeah, I changed that last night too. Using a dash map here as a channel ID to a channel stream. Basically, if there's a trait called deserialized, I can take a lifetime that represents the lifetime of the reader. So for example, you can implement a deserializer that borrows part of the reader, but your resultant type can only live as long as the reader because it borrows stuff. There's another one called deserialized owned, which basically uses 4a for the lifetime. The result is you can't borrow stuff from the reader. I didn't know about deserialized owned. Right. Of curiosity. data structure that can be deserialized without borrowing any data from the deserializer. Oh, wow. So this would be for things that are copied or useful for trait bound on functions. For example, from stir function may be able to deserialize the data structure that borrows from the input string. But from reader function may only deserialize owned data. Transient borrowed data, deserialize lifetime. And these guys are great at documentation. I want to be good at that. That is so hard to be able to write good documentation, to say. It's a special engineer that can do that. It just takes practice, right? Okay, now what do we have inside of this? I want to bounce back into trying to complete receive and add stream. Now at this point, we're wrapping a stream inside of an arc mutex here. Now this arc, I believe, is the one in standard lib. But we're gonna want the arc from the other place. So we want it to be a stream. It's an art too, yeah, absolutely. Basically, we want to add that. Let's... Did I call it async arc stream? Probably. Path is equal to dot dot slash. What do we call it? Async arc stream. Huh. It looks like it's right there. What am I missing? Async, ASYNC, ARC. Did I get the... Did I misspell it? Oh, I called it async arc scream. Cargo check real quick. Yeah. And I kind of like, I don't know, just a little bit more millisecond lag today for my keyboard. Yeah, scream instead of stream. Thank you. Yeah. The little voice at the back of my head must have taken hold of my fingers for just a moment. Alright, this is complaining about the return types. So from the channel, let's see, what is this? This channel here isn't quite a channel, this is a guard. We have to get the value off the guard. Let's rename this channel guard. Channel.value.next. Okay. Now next right there is next on channel. Got to select. So we're selecting inside of a loop twice. Basically so that we can guard against running the stream features dry. So we don't want to call this branch, this select biased, if there are futures, if there are no futures. So in that case that there aren't any, we will just select. There's no point in doing a select biased on one thing. Just select on that one thing. I say grumpy. Huh. Whatever. Okay, let's not fix that right now. So after we select, we'll do a process stream add in one case. In the other case, we do it as well, and then additionally, this process stream output. So this is a feature unordered of our arc. I don't think we actually need a mutex in there, do we? Because we can't just stream because of the arc. Let's get rid of that mutex. Yeah, that's from async mutex. Oh my goodness. Oops, jumped ahead. Alright. Because now we have stream on the arc itself. Shouldn't have to lock it. We don't need to await it. This should just be a dereference. Good. Oh man, this is lovely. Dropper into future. Falling bounds were not satisfied. Try future. It's not on there. No, we don't want future try future. We actually want stream try future. Okay, we'll come back to that one. Let's see. Now in this case, when we process the stream output, we get the stream ID. Check to see if the output was something so that we could re-enqueue it. The following exists were not. Okay, so this is the try stream as well, because stream there only exists for things that are try stream. Interesting that that's not the case for us. Why is it that our arc is not implementing try stream correctly? Because it should just be a pass-through. Jenna Zoe, thank you for the follow, and Jack Zuck, thank you. Did I say that already? I might have said that. Well, thank you twice. All right, let's go back over here and look. Maybe we should add some unit tests here. Oops. Test module tests. Stream. No test prelude on that. Now in this case, let's just create a stream. How about this will be an arc new of cursor? Let's have a vector with a cursor. No, let's just vector view weights. Do a range 0 dot dot 100 dot collect that. Can we not collect a range into something like that? That's not going to change that, but I thought you could collect a range into a vector. Okay. Let's pull that in. Where is cursor on the standard lib? Standard IO cursor. Huh. Can you map this? Just want to see, does map actually work on it? Oh, it does, okay. Oh, it's because it's integers. My mistake. There we go. Vector of U8s, range of U8s. There's no into or from a range into a vector? Really? Let's take a range for a moment. As iterator. So we can call iter on it. And then we should be able to then take the iterator into that. Because what does it say? It's an item of A. Yeah, I was trying iter.collect and it didn't do it. Oh shoot. That's because I forgot the parentheses. Into iter, and we collect on that. There we go. You need the parentheses. Otherwise, I think it binds to the last piece of the range somehow. That was interesting. Collect was there, wasn't it? Ah, yes, collect works as well. Thank you. We'll have a stream here. Great. That took way too long. Oh my goodness, it's early. All right. Normally, you're a beginner, just going through the documentation with you. Oh, thank you. No, I appreciate it. And some of these things, and this is going back to what I was saying earlier, Rust is like vast. It's like really, really broad. And to really get good at this, you really have to get into like each of those little APIs, understand like why doesn't a range have an iterator on it, or why don't we collect using an iterator? This range does appear to have an iterator. Actually, that's a question I have. I don't know if it's a good question, but it shows iterator here on a range, but it didn't have it earlier. So if we, just for giggles, toss that on there. What is the type of this? First, yeah, sure. Yell at us, please. Semicolon. Yeah. It's a range, right? It's a range of U8s. I get that. Now, isn't a range supposed to have an iterator? Oh, it is an iterator. It implements iterator. It doesn't have an iter function. Oh, my mistake. There it is. The range is, yeah. Thank you, Xenocron. It is the iterator. All right, I think we're up to like, 1.5 cylinders on the old V8 this morning. All right, now stream dot. This is going to need to be inside of some sort of async. It kind of seems okay and weird at the same time that it implements iterator. I think it's okay. I just had to see it right. Hey, we got a couple of deer in the yard. Looks like a mother and fawn. I'm gonna text my beloved. I'm just taking a moment. Oh my goodness. They're gonna move so quick. They're gonna move so quick in a moment. The fawn is approaching this motion. Oh, is it 2 does? A couple of doe. A young one and an older one. Oh my goodness. They are lovely. like it when I mute myself to cough. That's great. Alright. The deer are walking away from the ducks. At least one was. Like, we're leaving those things. Alright, so what are we going to do with the stream there? Stream next to wait. It's saying that it's not used. Did I spell that wrong again? Unused variable stream. Those are named exactly the same. It's just not oh, there we go. Good. Only allowed inside of async blocks. Let's use small for testing this. Oh, hey, vimrc. Actually, it's called dot files here. Good morning. Yeah, you're welcome. Is there a commonplace? Is there a page that lists all common Rust macros like printline? Not that I know of. Alright. Cargo add. I want to do small. Does small have a little testing thing? I wonder how Twitch extensions work. Maybe you could, which are the pulls available commands from Capitan. That'd be cool. That I would actually like to enhance Capitan to be able to spit out its list of commands that it knows. We actually built Capitan here on stream months ago. It should be at around ranges. Yeah, I mean that felt natural to me too. All right, should we add small? Oh, we could just use multitask. Let's go look. So what does multitask give us? Oh, it's one word, isn't it? Not two. There we go. Because yeah, we just want some simple, easy executor here. Is small really small? It is actually. It is very small, and it's actually broken into a bunch of different components. So it's pieces you could use to build basically your own small. So it has async task, it has multitask, all these different small pieces that just come together to form small. Small itself, I think it's 1 or 2 lines. What? Not lines. Files. And the performance is really good. So let's see, let's take a peek at the repository. But if you look at the source on this, one file 6 days ago, 200 lines, right? It's just dependent on a number of other pieces. Async task executor, async IO, blocking, futures lights. So all of this has just been broken up and is available for you to use in your own things. And we do use that in other places. My wife's asking me if they're mule or white-tailed deer. I don't know. Yeah, they're still out there. They're eating the grass. Let's see. Sorry, give me like 2 minutes. I want to look this up. How do you tell the difference between mule and white-tailed deer? Alright, whitetails almost always have brown rumps. The tail, I think of their tails down at the moment. I can't see on the antlers. These don't have antlers. Body size seem female. The attitude. Whitetails are much more aggressive than mule deer. Interesting. Darn it, I want pictures. Some people get angry at people that collect antlers, and just as a public service announcement, they drop their antlers. You don't kill deer to collect antlers. You can just walk through the forest and pick them up. And so if you ever see somebody with antlers on their walls, they may not have actually killed anything. So don't hate them for it. They might have just been on a hike. Same with elk. I'm guessing that these are white-tailed deer because of the brown face and white circles around the eyes. Yeah, and the ears are smaller in proportion to the head. They seem female. Alright, back to code. That was our lesson on deer today. Back to the code. Now, that's right, we were trying to figure out, do we really want task? I think we're just going to use multitask. Why multitask? Why not just small? Small does pull in a lot of different things. Alright. Oh shoot, I didn't want it like that. I wanted it dev only. There, just for the test. Oh, they're eating the herb garden. They are so careful about where they put their feet. He was on a dirt road one day and there's a springbok on the road. They basically ran slowly away, but still on the dirt road. You're gonna go 5 kilometers an hour on a 5-kilometer dirt road. Oh my goodness. That's great. Alright. Man, I'm like hacking up a lung today. Sorry. Alright. I'm thinking that I actually want to use small instead of multitask. Because, let's see, where's multitasks? Right. if we look at the documentation for multitask, yep, we can create one, spawn an executor thread. I don't really want to do all of that just to run a test. Let's just toss small in there instead. Cargo. There we go, multitask. Not going to change much. Give it a little check. Huh. Yeah, they're just out there chilling. That's crazy. I don't usually get to see them for so long. I'm slightly distracted. Here we go. Starts a thread local executor and then runs the future. This is what we want for our test. That should work. Small block on. Oh. Connection is disposed. COC just gave up the ghost. Let's restart COC. Alright, so small block on. We go to an async block. We do a task inside. We await the task. Let it format that. Is it that way? No. I mean, really, it's this piece here that we want to test. They basically made you chase them for an hour? Guess we could do this whole thing in that block. Simplify it. I'll have to get the test to fail though. Alright, now this is good. So we need futures ext pulled in. Stream EXT on that. Good. No method name next on arc cursor in the current method. Following trait bounds were not satisfied. Futures course stream, which is required by arc. So why doesn't it? I mean, really what we want in the other one is a tri-stream, right? Where'd it go? There. So why doesn't it implement stream properly? Cursor, vector view aids. Just because it doesn't have the right kind of return value for that? Maybe this should be a set of results. I guess for our test, we really want this to be a collection of results. There we go. So try next, try stream EXT, okay. Following trait bounds were not satisfied, try stream, which is required by such and such, blah blah blah, result. Is it all targets? There we go. Do we at least get the types correct? We have a result with OK and error. But why is this not implementing for it? Yeah, let's work backwards. Got a vector view weights with a cursor instead of an arc. Should be our arc. Now, one thing I noticed in the other library is they didn't have this here. And I was wondering if that was an oversight or intentional. Because do we need T to be unpinned in order for the arc itself to be unpinned? I guess we could move the arc around in memory. Let me move. But does that mean that T can't? Because the arc's really a pointer to this other thing. So seems like in this case we probably don't need it. Alright, but here, this stream is saying this doesn't actually exist for that. Is that because we didn't put a borrowed T in there? I mean, that's just for T. Huh. Maybe it's because it's not done. Maybe it's because of the unpin constraint? Method try next not found for this. Try stream ext. Okay. We could try looking at. Let's see if we can just pick this apart. So what's up? Why doesn't it like this? Oh, we have stream. Stream should be of the right type. Oh. I edit anyways. Just open somewhere else. Go figure, huh? Alright, so yeah, stream is open. We are using the right stream. That was from Futures. If we did this also for TriStream, it's not going to help us much, is it? Ah, good. Conflicting implementations. Oh, that's an interesting way to get it to tell you what it sees, isn't it? Just toss up some conflicting implementation for it. Huh. What are you telling us? Conflicting implementation. Yeah, okay. So it does see this as an implementation of it. Do I not like Shift K? Shift K works. Oh yeah, good point. Well, I was hoping that it would tell me, like, yeah, it's much less. I wanted more info. Have I used VS Code? I have. I don't really care for it. I do prefer Vim. I think this has to do with the type that we're actually providing it. Maybe cursor isn't unpin or something else. It's just not fitting this. Oh, you know what? Unpin actually works there. not including, excuse me, removing unpin on there. Debugging is pretty nice in VS Code. And would it help in this case? Because, well, there's pretty much the same information. We're using Conqueror of Completion, Rust Analyzer. There's a little bit more information in VS Code. Integration's a little tighter. I don't think there's much. I think this has to do with the lifetime on it. Oh, the item! We didn't... Oh, shoot. Is this extra item actually tricking it up? I don't think so. I think it's just associating those elements. Is there a different way to do this? For example, if we had T there, and we had stream, just, you know, normal with a comment, how you would do this in every other situation. This is how I would expect to do this. But this for lifetime A syntax has messed this up a tiny bit. Now there's the associated type item is not found for T. Which surprises me. Is this really just giving us a constraint on, like, what is this constraining? Is this, what does it say? The lifetime A, so for all lifetimes, a borrowed T, in this case, is a stream. The editor wars have begun.
People that are different have a shot at being original. You know, they got
Huh.
motivation too.
Associated item
They got motivation.
not found for T. Would these conflict? Do those actually conflict? Why doesn't it say that they conflict? Oh, interesting. It still doesn't implement that. Why not? Okay. Where's stream? Pull next. Oh, you need the T as blah 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 spiel. Oh, really? Kev hasn't. Those look the same to me. Oh, there we go. Stream's not implemented for T. So this doesn't actually constrain T the way I thought it would. Okay, let's try to figure that out. Turns out this is going to be a little bit more of a discovery and learning sort of stream. It's implemented for lifetime V for a borrowed T. Interesting. I mean, can can we do that? You try the Vim emulation layer, DilyJ? Missing item, pull next in implementation. Okay, well that's interesting. So how is it missing item? These it's not matched up? Should be. Oh, strange, it's not actually going to that. This might be in GAT territory. Oh, don't say that. No, 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 no. Seriously? But you're right. Immediate denial. We need like a monster that represents a GAT. Alright, nope. Parameter T may not live long enough. Static T does not outlive them. Yeah. Interesting. So the goal of this was to implement a stream or an arc of T, right? Here, let's do this the other way. Let's see if we can pull that off there. Okay, this get us to that point. Now the problem is going to be here, where we try to call pull next. Alright, now in this case, so pull next requires that you have a mutable reference to self, right? And this is saying that we have a mutable reference to a borrowed self in the current scope. Can we just remove this T cannot be unpinned. Cannot borrow data in an arc is mutable. So why was this working? Why does this work for them if they're using the lifetime constraint as opposed to the kind of plain T constraint? Hey Berduda, how's it going? We're in higher rank trait bounds territory here. Your ref mute is required to modify. Just in time for the red text. Oh my goodness, this stream started with red text today. Yeah. For this lifetime. That is like that. Now, we can kind of loosely associate these things. But provide that, say, item is equal to item. Let's just give it I. I don't like the repetition there. And in this case, it's happy to compile. It's going to want this 2018 idiom thing. So this compiles, but now we have trouble actually providing it something that actually matches this constraint. So how do we provide a T that matches this? Godot using Rust, yes, good morning. We're definitely on the Rust side today though. Alright, so how do we provide an arc with one of these such that it doesn't freak out? Technically that doesn't need to be unpinned there anymore. I think it's just a reference now, isn't it? So we're not getting the right type here. Now this arc, so that we want this to be, can we give it a stream? I want to constrain that somehow. I know it's unsize type. In this case, we can't give it mutable references to these, but man, I can imagine having just like tons of lifetime issues because of that. All right, now if we go back to async something, async 2. Now in these cases, this is the code I was looking at. The impl t, async read for arc t. Very, very similar to what we're doing. In fact, the code that's up here, basically everything from this point up, is in the top of the file that we're using. Am I somehow constructing this incorrectly? Because in the example, just create a new arc stream. Okay. And then you can clone it. Interesting. I wonder if our test here. Oh, there's no magic in the clone. Why is it actually needed for ArcT? I think that it's needed because of actually I'm trying to understand this. So the code that I basically pulled this from is from the crate async dupe. Okay, async dupe does a fantastic job wrapping async read and async write types in an arc, and then providing async read and async write on the arc itself. Okay, now what I'm curious about here is how does it actually do this such that it doesn't need the interior type to be mutable? Well, rather, because it's an arc, right? You're not supposed to be able to change the like you can't get a mutable reference to the thing inside the same way. If you wanted mutable access to it, you'd have to use a mutex and do locking and whatnot, but they're not doing that here. They're just not. So I'm trying to mimic this. And in this case, they're implementing async read for this type, for an arcT, right? And this is their type up above. If you look at their type definition of arc, it's just an arc. It's got a new type pattern. Yeah, I want to understand this magic because this is next level stuff. And I think they're like, if we can understand that, that would be like really, really helpful because this pattern I do all the time. But there's a little bit extra in here that I don't get. Oh, we've got an arc. We've got unpin for this arcT. I get that. We can implement new on this. Clone, I see. Okay. Yep, they're just cloning the inner arc, creating a new one of themselves. Deref. It's inline target of T. Yes. Get it. You didn't know Rust was still used in 2020? Yeah, Windward Hive. It's picking up steam actually. We've got pointer, default, etc. from these things. From T4 arcs, a little constructor thing. Alright, then he goes on to say, it would also make sense to make these possible, but it results in some pretty gnarly compiler errors. Yeah, Namicon doesn't have much on this. Rust is probably the most trending language in 2020. Good morning, Pew. WTD. How are you doing? But just looking at this first impl here, right? Async read on something, or at least an async write, right? Async write definitely takes something that's mutable inside of the arc. It's doing a pull right on that. And it just works. So why are we having so much trouble with this for stream? Is it just not possible? I'm doing well. Yeah, it's been a good weekend. Took a long weekend. So today's going to be D&D day with the kids. Daughter's running a campaign, and she has yet to kill us all. Yeah. All right, here's another one. Need to give my brain a moment for that. I used to have a fear of hurdles, but I got over it. Oh, there it is. Fear of hurdles. Got over it. Why do you see a lot of reborrowing? You just don't understand the 4A. 4A is basically declaring a lifetime. It's saying we have a lifetime A that represents all lifetimes. So in this case, this T, this borrow of T for all lifetimes exists for an async write. Or yeah, we're only implementing async write here on arc for a borrowed T of all lifetimes. It's for higher rank trade bounds. Okay. We cannot know the lifetime, we just say it for all lifetimes. So then why is this working for them and not for me? A little upsetting, I have to admit. So basically we're doing like this. Look, let's just take this flush here, which is of course mutable. There's nothing else going on in here. Just take an extra character off that so they line up right. I mean, that looks great. No, you forgot about variance and had to study it again. You know, I was actually reading it this morning. Very briefly, actually. Not much. It looks like this is quote-unquote correct. The thing that might be butchering it is because of this I here. And constraining this here. Yeah, variance and omcon, that's correct. Cursor vector arc. This is our arc, isn't it? Yes. We should be getting that from super. Could be explicit. I don't think we have any other. Oh, we do have the other arc in here. Oh, how do we test that? Because oh, good. It's actually very explicit about where it's used. Okay. So we're not going to have a name collision on that. I needs to be bounded. There's no next right there, only pull next. Yeah, let's go pull next on it. Just well, thank you. But in this case, no, we call next because next on stream, right? The stream EXT ends up providing a next, I believe. Oh, wouldn't that be? That would be embarrassing. Gonna close some of these. Sharded slab, sure. Ah, here. So for stream, got pull next there. So as long as we implement this, then we should be able to get a hold of stream EXT, which should have a next on it. Here. And this is the interface I'm trying to use. So I want to make sure this works. Yeah, we're implementing stream for Arc. This is basically for our type here. That would be awkward. We know that's fine. This super thing here actually pulls in the traits from the import up here. So it's pulling in all these into the test scope here. Man, without this, the other design just doesn't work. I wonder where this is failing. Let's put a type result here. Just give it the same thing here. Do stream await. Oh, there's no issue with the design. Yes. And Virsa. It is possible with GD native. Because when you await, you called pull. What you do pull next? Stream. Yeah, Stream.await? No, we need to call the function on it. The trait bound arc is not satisfied. Are you kidding? I'm not sure why anybody should pick Ruby over Node. Yeah, I'm not a Ruby person. All right, let's put those back real quick. Hi there. What are we actually awaiting though? Yeah, it's not a future. So we do have to call next on it. But it's no use, 'cause you can't stop it from shining through. It's true, baby, let the light shine through. Rust is part of Ruby or Rails? No, no, no. Rust is its own programming language. All right, yeah. I don't think that's actually the issue here, but we'll give it a go. There's StreamXT. And stream on that. I mean, I'm guessing that this is a little bit more of a GAT issue. Even if we did this, though, it's still not working. And that should be the type that this is basically constrained to. I mean, that stream should have an item with a result, U8, blah. So if we look at this, wait, does cursor implement, oh shoot. Does cursor even implement stream? I was thinking async read and async write. What is it? Cursor. No, not that one. Standard IO cursor. Go back. Oh my goodness, I was thinking of the wrong thing. We can't do it with this. That is absolutely broken just because the cursor type. Alright, well that was embarrassing. Well, no, that was a good learning experience. Let's use some of these to actually create. How about repeat? There we go. We'll just use repeat to create one of these things. Produces the same item repeatedly. That should be possible. Gonna give it something. We'll give it an OK with the number, I don't know, 42. Ah, it needs to know what he is. Unit type there. Okay. Expected one argument, found two. Ta-da. Okay. Can up our data and dereference of arc future. Oh, interesting. But it's not implemented. Oh my goodness. Yes, it was the cursor. Oh, we were cursed by the cursor. All right. For a moment, let's see if we can toss an eye back on there. There we go. Here's you, cursor. All right, now it was saying that we cannot borrow data in dereference of arc repeat as mutable. Deref mute is required to modify through dereference, but it is not implemented for arc future repeat result I32. Alright, which one of these is the culprit? Is it repeat? Right here. What if we did something other than repeat? Maybe it is repeat. A stream of a single element. Interesting. I wonder... Is it parens comments for the previous or the next? When you implement iterator for something, you see a lifetime iter, say, in case of slices. Huh, interesting. Yeah, I'm not sure on that. You know, borrow data in dereference of that. So we could just create some other sort of stream, or we could try to do something else. Stream once. Although I think it says it might be that other bit. Oh, and we give it a future. I see, not a result. Type inside async block must be known in this context. Huh? Infer the type of the sure, use size. Okay. Cannot be unpinned because it requires within that and that. Yeah, I don't think that's actually needed up there. I think we would need a better stream here, like the instead of this once, and it might be okay. I meant to say you don't see iterator for arc, T-O-R-T, iterator, because the lifetime disappears with the arc, and is wrong because you only really know that there exists a lifetime and not for all lifetimes. I see. So iterator, yeah, it doesn't exist for all lifetimes, only for the lifetime. Yes. Wait, cargo check. Alright, so it needs to be unpinnable. Now there are some streams and features that we could probably use for testing. They're over in Tokyo though. Tokyo Util might actually have better test setup. No, is it actually in Tokyo? Tokyo Test maybe? Okay, and that just implements async read and write, not a stream. Seems like it's much harder than it needs to be. All right, how do we create a test stream? Just want a simple test stream. A kind of semi-realistic one. We could go back to the cursor, but then also toss on top of that a codec. It'll give us streams. Directly use Tokyo and GitHub directly. All right, well, let's ignore this for just a moment. Now, I don't think we actually changed anything in here today, right? Like this is everything I had this morning. And then when we try to use this over here, it's not, let's see, is it going to pick it up? Maybe we did change something. Straight bounds not satisfied. Expected type parameter, st, okay. Bound struct mutex. Let's clean up some of these. Source lib. Gonna close some of those buffers. Oops. There we go. Now in this case, we do not want the mutex, just the arc. And this should be our arc, shouldn't it? Yeah, that's ours. Let's get rid of that mutex. So this is the case where we're actually sending. We get an iterator thing full of stream IDs. Man, I feel like Rust just beat me up on this one over here. Like usually I can come out of Rust feeling like, hey, I'm okay, I made it. Now in this case, if it's not, okay, there's this one special case where Rust always wins. That's currently with GATs. I find myself in situations where I want generic associated trait types. Yeah. And that's just always a game over because it's not supported yet. Haskell boys can solve such issue easily in Haskell. I've heard good things about Haskell. And it might be interesting to kind of pick it up just to learn Rust better. Because the type systems, I guess, very inspired from Haskell's type system. No method send for this option. Okay. And where are we trying to send to a stream? Is that even correct? From the streams, we get that. Shouldn't that be a sync? This should be a sync, shouldn't it? Sync ext on that. Yeah. There's a function. We're looking for that, not the other one. Sync. Channel is both, isn't it? Miguel, good morning and happy Sunday. Rust and Godot, how does that work? And Dan Rubin, thank you for the sub. I really appreciate it. Oops, oh my goodness. GD native there. There's basically this project that lets you use pretty much any other language inside of Godot as a scripting language. And in this case, we're using Godot Rust. We're using the preview, the 0.9 preview 0 version of it. Occasionally, we'll try to send out little PRs or things that could help with that. Okay, but this channel, it does need... Oh, I see. No, I'm constraining that in the wrong spot. It shouldn't be like that. That stream should also sometimes be a sync. Ooh, that's kind of gross, isn't it? Let's change it to just T there. Now in this case, change all those to T's. And yes, that T is also a sync of bytes. Got it. They had a chance to use well-tested stuff. Oh, C++ routines only. GC native? Oh, that's interesting too. Madhouse Steve, good morning. Yeah, I haven't tried the C++ stuff. There is a Discord channel that I kind of listen in on. Oh, the GD native, yeah. No, GD native is basically their plugin system. It's basically a system that allows you to write any sort of DLL or shared object that can be loaded into Godot as a scripting language. So while we say scripting language there, it's really any compiled code can be used inside of GD script. Inside of Godot as scripts on the scene nodes. Now in this case, we have async move, and we're trying to send data to it, and that's okay because it's a sync as well. I didn't see that before, but that stream is a little off. Maybe we should call it a sync here. Stream IDs, sync IDs. Yeah, whatever. We'll just know that all of our streams are also syncs. Sending data via the stream. Actually, why am I calling next await on that? Did we have before I did all that? Oh, stream.lock.await. Oh, okay. It was just, we were locking it. Got it. So we don't actually want to pull the next thing off of the stream. We're just going to remove the lock. Ta-da! Cannot borrow it as mutable. Okay, now in this case, we probably need to also impl sync for this. You haven't done Rust in the longest time? Oh, async await is part of stable, yes, as of, what, last November? Wow, you've been, yeah, you haven't used Rust in a while, huh? So, Tokyo is not stable. Excuse me, Tokyo is not the standard async runtime. There is no like proper async runtime. Because there's just features out there. You can use Tokyo, you can use Small. There's actually a little handful of them. Tokyo, Small, then there's also async standard. Don't let the name confuse you, it's not actually the standard implementation. And then there's also multitask. The last three are actually all using the same kind of core runtime. So if you're doing it like a runtime comparison, it's like the three on the right versus the one on the left there. So it's Tokyo or the other ones. Async standard happens to be using Small, which in turn is using multitask internally. Yeah, that confuses many people. It really does. Now, what's going on in this case? Yeah, you're welcome. But I mean, quite frankly, if you look at the small source code, it is tiny. Like the amount of code in it is small. I think when it first came out, it was like 1,500 lines of code, and it's been broken up into a number of different crates, so you can kind of it's a little buffet of async stuff now, and you can build your own stuff out of it if you want to. You've only been doing Rust a couple weeks. Oh, that's wonderful. Yeah, Rust is fantastic. It solves so many of the issues that have plagued me in the past. Alright, so what is this actually saying? Cannot borrow data in dereference of arc. Okay, so as mutable, deref mute is required to modify through a dereference, but it is not implemented for that. I thought deref mute was in there. Oh, but not for T, not for of type T. That's in our third window over here. Let's go back to lib. Oh, we have deref. We don't have deref mute. See, we should be able to get that though. Because in this case, we get the streams. The streams has the arc. Interesting. It kind of gets me. I think that we're actually going to run up against something here that's going to break the whole thing. Here, we're trying to send this data out to these stream IDs. We iterate over those stream IDs, building futures out of them, okay? That's what the return type is going to be here. Now, here's the future, right? This async move block. We're actually just returning that entire block. But we have to pull a little bit of data out of some data sources first. In this case, we get this arc. This streams here. It's a slab to arc T. And in that case, our T is that stream and the sink, of course. Now, we have that stream. We try to send data to it, so we're trying to call the send function off of it. Now, which guard is that? That's the guard from the slab. Not bar data. Oh, you're desperately trying to debug a seg fault in C. Speaking of reasons why Rust is cool, I've only ever been able to get seg faults in Rust using unsafe code. Okay. Before Rust, C was my favorite language of all time. I love C. I absolutely love C. Gotta go with what's already done, yes. Oh, oh, best of luck with that. Hopefully you'll get it soon. Not implemented for... Okay. And what else could we do here? We're just trying to send to that. We've got the guard. We've got the arc. Can we rebind this? I mean, that seems silly. It's basically not going to do anything. Having this mutable not going to help it? No. See, I had wanted to use this lab. I really wanted to use this lab. But I think it might actually be better for us to use like dash map or something in this case. Because we did just remove all the mutex stuff off of there. And why did we remove the mutex? Okay, so maybe the mutex stuff has to come back then. Let's pull that back. Okay, mutex stuff is back. Problem then is that we have this arc mutex here. See, I think the mutex is going to be an issue because we're going to be blocking on these things. As we try to read from them. This is one of the reasons I was trying to split this up into like a sync and a stream. But use arc on it, kind of like how async dupe works. Because if we look at async dupe, and just in here, it implements async read, write, and sync. Okay. Yep. Wrap an IO in that to clone it or share among tasks. Share an async IO handle. Yes, toss it in mutex. Is using arc so it can be set. What's that? Oh, hey, I missed some. I mean, you must be using an arc for thread safety. So in Rust, TCP streams are not they've got a little bit more oomph to them. So basically you have an owner of a TCP stream, right? And so if you need two things to have access to this TCP stream, you have to toss it into something that can do that, where you can have shared ownership. And Arc is a good way to use that. Yeah, so you can clone it cheaply. Now, the problem then is that in order to be able to mutate these, let's say read or write from it, you would then have to lock if you wrapped it in a mutex, right? Dang. Man, this is bugging me so much. So I love the way that that this works for async read and write. But I think in many cases, I actually can't split this up the way I want to, because I want something that's always reading on the socket, right? If a packet comes in, we want to know about it. And we don't want that to block being able to send a packet to the socket. So if we have to lock something up in a mutex, that's going to be an issue. Unless they have some sort of fancy mutex that does some... Is that a true mutex? Or does it just look like a mutex? Taste like a mutex, smell like a mutex. Pub sub? See, in Tokyo, you would actually split this into two pieces. So if we go back to Tokyo, you can call split on something, right? So a TCP stream has a split, so you can have a read half and a write half. And then you can read and write from this at the same time. And this is what the existing stream multiplexer used. Right, we were actually using this. And it worked really well. I was just thinking that maybe there was this other way to do this. So maybe not. It's too bad. There's got to be a way to be able to send to a socket and also read from it at the same time. That's kind of the crux of this. Now you were saying, pub sub. I don't. You think you'll start reading all the source of Rust Future? I don't think there's much for Rust Future, right? Right, 120 lines or so, yeah. And most of it's comments. Oh, the future is great. Yes. Gotcha. Okay. Change something up here. All right. So yeah, I was thinking that we could actually use this for being able to read and write concurrently. Like, is that actually possible? Or where's my notes? Okay, some notes up here. I think it must be possible. Tokyo does it. New Futures is based on vtable. Oh, interesting. All right, let's look at Tokyo again. Now, the place that they do this isn't actually here. It's in Tokyo IO split. Yeah. So you end up with a read half and a write half. And they have an unsafe cell with a stream in it. Yeah, and then you can join them back together if you want using unsplit. they just have this little bit here to know whether or not it's locked. And in this case, they implement, read and write for each one of those halves. Arguably, they could have just actually, how does this work in the case where I'm constantly locking on this? Are we able to only lock if there's a signal on it? If there's like a waker? Alright, let's look. Read half. So if we're trying to do this, okay. Is pair off? Yep. Unsplit. No, don't care about that. Async read on this. What do we have here? Already. Yes. Poll lock. So what is this poll lock doing? Poll lock. Self-locked. Compare and swap. True acquire. Okay. Spinning, but investigating a better strategy. I see. Oh, I see. You'll now wake by reference. Huh. Alright, so other than doing it this way, is there some other way to actually do that? Because we could split. Now in Unix, right? So if we go back to the terminal, command to read, right? You give it a file descriptor, and you can read from it. Yeah, in BSD sockets, FT poll will block unless passed a timeout. Yeah. Now, given the same file descriptor, we can read and write concurrently. And Rust must be just doing this under the hood, right? Like, it's just wrapping these things, and it's provided some type information with this. Is it unsafe time? Not yet. Oh, my wife's sending me a photo. Alright. Looks like the deer went after the tomatoes. So why is it that they're guarding against this? I could see maybe having a read lock and a write lock, saying that you can't read from two things at the same time, or more importantly, you can't write from two things at the same time. You don't want to have like interleaved bytes going out. Because ideally, we just care that we can read and write. We'll never have two writers at the same time, never two readers at the same time, but we want to be able to read and write at the same time. Huh. Anybody know if there's a way you can do that already? Yeah. I'm playing in our full lock. So in this case, we'd be ready, and then in this other case, we yield, and we say we're pending. So what does this do? This returns a guard. Right? It then says it's locked, and then if we go to try to write to this, we can't. Oh, that is so weird. I mean, other than having like a bunch of channels and then maybe can you read and write? Let's go look at, let's start at the base. TCP stream. Yep, connected to TCP listener by reading and writing to it. Close when it's dropped. Alright, trait implementations. You can read and write. Takes exclusive to read. What about for writing? Yep, right, same thing. As you would expect, right? That all makes sense. Now, I just don't like this. Because we should be able to read and write at the same time. Well, I guess unsafe sell for that, right? Quick reverse. Unrelated but funny. You have your C vector, you push a struct into it, pop it back out, and it inverted the byte order. Oh, that's funny. Yeah, you should be able to do it like BSD sockets. Hey, Kent0456, how's it going? Good morning. Yeah, you should be able to do that at the same time. Now in Rust, because you're mutating it, you have to have an exclusive borrow for read and write. Now, if there was a way to be able to say, is there readable data without actually doing that? So if we could peek, receives data on the socket from remote outage, okay, without removing the data from the queue. Interesting. So you can actually peek and look. All right. So now, this interface here isn't very asynchronous, right? And I think the waker for this read and write, like whatever that triggers the waker, be it you know, KQ, select, epoll, right? Yeah, I think Tokyo is using MIO. Oh, no, not over there. Or did they move away from it? Go to latest version. Ooh, 0.7 came out. Did that fix some Windows stuff? I mean, maybe our problem is that we've been using the wrong layer. Token, waker. Net. Okay, we got some TCP primitives. TCP stream here. You try not to make any assumptions? Yeah. Features library can split stream plus sync into reader and writer half. Yeah, it can. I just does the features library also allow you to write and read at the same time to each of those? I actually didn't see that before. Do you have a link? Let's see. Oh, I see. So you can split a stream. Interesting. I wonder how they do that. Reunite. Okay, this looks very Tokyo-ish. I don't think this used to exist. Bitlock option item. Okay. Because you're right, as the stream comes in, we can actually push one into one half, into one collection where we're storing all of the readers. Right, those basically go into the futures. And all the writers go somewhere else. Oh, your pop was broken. Oh. All right. Well, that's cool. That's really neat. just what are they using? So in this case, okay, so their implementation of stream for that. Pole lock, where's pole lock? Self.0.pole lock. What is .0 on there? Self is a split stream. I think we were looking at that just a moment ago. It's a bylock. What is a bylock? Lock? So it's from this crate. Type of futures powered synchronization primitive, which is a mutex between two possible owners. Primitive is not as generic as a full-blown mutex, but is sufficient for many use cases where there are only two possible owners of a resource. We optimize for just two possible owners. Okay. Or data which serves two purposes, wants to be split into two to be worked with separately. For example, TCP stream could be both a reader and a writer, or a framing layer could be both a stream and a sink for a message. Oh, neat. Okay, so it's only available if bylock's activated. Wada77, good morning. Okay, that's I get that. So I see. So now, one thing that was troubling me was trying to figure out what it is that actually triggers something to be pulled, right? Because it looks like some of these things, it might be possible that they're only locking if there's data to be written or data to be read, right? Now, in this case, it would only do it if, well, there was the demand for writing, right? So if you call socket.write, then it's going to try to perform that write operation. But what about read? This is usually going to be handled probably by like MIO or something behind the scenes. Sorry, hold on. My wife is texting me a lot. Let me check. Oh, okay. Yes. Now, does read only lock if there's an event? I'll bet that depends on if you're using something like MIO or some other library under the scenes, behind the scenes. So maybe this doesn't care then. Yeah, is she in the stream? I don't even know if she's in the stream. Oh, it doesn't look like she's in the stream at the moment. She will occasionally be in here, and her handle is just like mine. It's MRS, a whole Z. Alright. So maybe I'm just thinking too hard about this. Maybe this is just not something we should be worrying about. Because as I'm thinking about two different places. I'm thinking about stream multiplexer, right? And stream multiplexer is really just getting the streams. So it doesn't know what sort of locking is going on. It doesn't know these things. But it would be nice if it could both read and write at the same time. So maybe we just try to use that that split. Now, where was that? Was that on StreamEXT split? Oh, look, they're using self as a constraint there. That's awesome. All right, we'll do that. I think we've already got standard or alloc activated. All right, so how do we use that here? Where are we? Add stream. Let's start at add stream. When a stream comes into this, let's get ST here. Right, that's our stream and our sync. I kind of want to rename that. I keep looking at ST thinking, oh, you know what, this is just, it's a stream. But if I say it's a T, then it's less generic and I'll think about it a little bit more. So in our case, we want it to be a tri-stream and a sync. And our sync here, we actually want it to be the same type as this. So T, okay. Oh, what is the 8/1 in the title supposed to be? Oh, that's yesterday's date. That's right, I was going to change this today. 2020, 0802. It makes exporting these much easier. Because I'll go through and I'll export them and kind of archive them over in YouTube. Because they only stay for like 60 days on Twitch. But then I lose like the date information. So I have to make sure to either like transcribe it right or something, I don't know. Okay. You were the first person I worry about when I wake up, and you were the last person I have on my mind before my eyes shut, and that's where I see you in my dreams. We're happy. I see, and we would have to know what type that is there. So in this case, we could say T tri-stream, where OK is equal to I. There. Now they'll be the same thing. Because in my dreams I'm living with you, but in reality you're threatening to move out. Realistically, it's always going to be bytes. You never know. I think I had been trying to be a little prescriptive somewhere else. Yeah, now in this case, let's go back to add channel. So when we add a channel, we have the, no, not channel. When we add a stream, we receive the stream. It's a sync and a stream. And the ID, like where do we want this to go? We want this to go into that channel there. Yep, make sure we have the channel before we add the stream to the slab. fine. Let's see, in this case, we add it to the slab. Do we want to split it before adding it to the slab, though? Probably. Because why do we store this in the slab? There's two reasons. One case would be yeah, what are the cases? When we want to send data, right? We have to look at the sink in the slab and send data to it. That's one reason. The other reason is to be able to move these between channels. So if somebody says, hey, move this, sorry, if somebody says, hey, move this to another channel, we want to be able to take that out of there and move it to the other channel. So what we were doing is having a way to drop the existing stream out of the futures unordered collection, and that works. But then we need a way to be able to add it to the next one, the next channel. So maybe we do have the arc for that. Yeah, for the stream, but what about the sink? I don't think we need it for the sink. It'll just always be there. Okay. Maybe I should move that big block of text here to the bottom of the file. Keep going to the top looking for bits of information. And those are really just notes. Alright. Notes are at the bottom now. Yay, now we can find this. Okay, we have it. Streams and sinks. Now in this case, it's not going to be a T. Ooh, interesting. Because this isn't going to be that type, is it? The dash map is for the channels, and the channels have a T, which is a stream. Oops, wrong thing. Interesting. Now in this case, where this is those two types, I mean, should we actually split this up? No, we don't have two types coming in. We expect the same type though. But down here we're actually going to be splitting it. Ooh, interesting. Now, how do we represent that here? I don't want my head to keep spinning. Huh. Oops, this should be ST and that. Oops. Come on. Stream and sync. There we go. That's better. Now T's gone from there. Now at this point, I mean, we could ask that they split it before giving it to us. That'd be possible. I'd prefer to just split it ourselves using this. Oh, you know what? Maybe we should be using these types internally. Split sync, split stream. Is that where? Yeah, we're gonna need to know that and have to store that somewhere. Okay. That's off of T, and this is item. Do we need the mutex in that case then? Probably. And that mutex should be... Does it need to be async? Yes. But for the streams, I think it just needs to be an arc at that point. Okay, let's undo this a little bit. We're going to say that's still T. However, in this case... Hey, ActUndev, how's it going? We need a split sync and a split stream. So we're going to be calling the future split on that sync ext. It's going to be an arc for the thing on the outside or the inside? No, we're going to put it inside of an arc because we're going to take ownership. We're going to wrap it in an arc. But do we split it first? We must have. Yeah, we have to split it first. Alright, in which case this will be a split stream over T. And this will be a split sync. Yeah, in the sync we need the item, don't we? All right. Now, where are we pulling those in from? These are at Futures. I doubt they're in Prelude. Futures stream. Okay. Now this needs to be I. Streams and syncs. Or should they just be in the same one? They could be next to each other. Because essentially they're always going to be the same size. Streams and syncs. Could do some little tuple. So the first one is always the stream, the second one's always the sync. Or vice versa. I think in most cases we're actually going to be using the sync out of here. We'll only use the stream if we need to move it from one channel to the other. Because we'll end up cloning it again. Syncs and streams. I wonder, would we have better... Probably be better if these were separate though. Keep the data closer together. Changing channels isn't going to happen that often, but having more data in like a CPU cache would be helpful, and having that in the syncs right there would be good. All right, we'll leave that like that. Adding channels is fine. Using a dash map for channels, whatever reason. As channel, remove channel, etc. Send. So for send, we need the sync. So these are stream IDs. We're gonna get the syncs out of here. Self, syncs, get that stream ID. Clone the data before moving it in. Yeah. Your better TV emojis aren't working. Oh no. I don't know why. You have to do something for that? Like, what is it about that? I'm actually not a fan of whatever instrument that is they're using there. Kind of screechy trumpet. I don't know what that is. It's like a trumpet with a kazoo, but not like a mute, like a proper mute. Alright, now in this case, when we go to send, we can lock on the stream, that's fine. I play the noise. Yeah, like what is that, right? Okay, I don't know. I'm actually genuinely interested in what sort of instrument that is. That seems okay. So we lock on the stream, we send to it. It's a split sync, we should be able to send to it. Now, it being a split sync, do we have to lock though? I guess we only have to lock yeah, we're not taking a mutable borrow to self here, so can't really do that. We'll have to use the mutex. We wait on the mutex, get that, send it. It's just going to be a lot of locking on mutexes. The other option, actually, is to set up just tasks for every single one of those. How many tasks can you have running inside of, let's say, Tokyo or Small and still have it be performant? Can you have like 30,000, 40,000, 50,000? Let's say 50,000 tasks. And how would it handle that? This is what I'm thinking is, like, why aren't we just spawning up a task and associating a channel with this, and then we just dump to the channel like a npm CQ? All they would be doing is dumping to socket. So, current thought. Let's say you just had you wanted to send data out, right? So you had data come in. You found the npmc or npsc queue for a given socket. And then at the other end of that, you had a task, some spawned task. And all that spawn task was doing was taking data from the npsc socket, or the npsc channel, and dumping it out to the socket. I know my little ASCII diagram isn't the best, but could you do this for every single one of those?
Why don't you just come on over? Why don't you just stay with me?
Like, should we favor an npmc or npsc channel over a mutex?
All these years later, got me screaming like life is gorgeous and you add to the scenery.
Because there is There's a bunch of channels and stuff out there. There's like async channel. Channel is the center of the receiver side. Both can be shared amongst multiple threads. It just sounds amazing. Yeah. I wonder how well that would actually work. I mean, should we benchmark it? Could. Spawn some 50,000 tasks and feed data into via channels.
The night said that it's young and I'm relaying the message. Feeling good, a down to your luck. Do you wanna make out, baby? Do you wanna maybe lay under the stars and just stare up at affection? Don't think long, these are simple questions like I just really wanna love you.
That's good question.
And I just want you here with me tonight. Are you high on life? Are you down to your luck? Do you wanna make out, baby? Do you wanna maybe lay under the stars and just stare up at affection?
Stream crashed because computer crashed. Oh man. How many concurrent players am I aiming for? Well, let's go with some big numbers. Let's say 20,000, 30,000. Which is why I'm a little cautious on that. In that case, you'd only support benchmarking. Oh yeah, if this was handfuls, oh my goodness, this would be done, right? Sign you up for the alpha. Well, I will definitely be posting information about that once we have need for load tests. I actually wanted to do some load testing earlier this year, but never got around to it. Just to see like where the bottlenecks were, because I'm sure there's going to be some fairly obvious bottlenecks once you get a couple hundred people in there. It's always the case, right? Every like 10 orders, like every order of magnitude, you gotta change either architecture or the giant bottlenecks. All right. Cargo. Let's see, how do we actually use benching for this? Cargo bench. Compile and execute benchmarks. Fantastic. There's also criterion, right? Unstable, only available on the nightly channel. There are some packages available on crates. Yeah, we can use nightly for that, I don't care. Alright, and how do you actually write the benchmark? Have docs on that? Feature selection, targets, etc., offline. For benchmarking, I don't mind nightly. We could use criterion. Arguably, this might be a little bit better for documentation. Let's go ahead and do that then. Let's see, features, quick start. Oh look, bench. All right, dev dependencies, criterion, bench. Then we give us some information. Let's do that. Cargo add dev criterion. Cargo add criterion dev. I don't know if Fogger, yeah. Code coverage and benchmarking, the two things you still need nightly for. Oh. Unable to find. Oh, I'm in the wrong directory. Wait, create a new. Okay. What are we gonna do? Cargo. New. I thought we just did this. Didn't we just do a cargo new? No, we didn't. Okay, cargo. New. How about stream bench? Stream. Dash lib on that. Stream bench. There we go. Matplotlib? Oh, I'm not even familiar with this. This is OS 10. Cargo add. Criterion dev. There we go. Alright. Cargo. Check. Get that downloading. Now, define a benchmark by creating a file at project benches. Okay. With the following contents. While I run this benchmark using cargo bench, you should see output similar to this. Oh, neat. Okay. Yeah, OS 10. OS X actually came out after OS 9 and OS 8. You get the idea. But yeah, I'm actually a BSD fan, and in the near future I might switch out to a BSD box. I've been looking at these. Oh my goodness. They got these. Was it 3950X? These things smoke. Yeah, these things. Specifications. Gimme. Really? Where's the spec? Oh, here. I missed that. Okay. 16 cores, 32 threads. Oh, that'd be so nice. That, and it supports the PCIe 4. You toss that on there with some NVMe. Oh my goodness. Got a 3800 with only has 8 cores. Oh my goodness. I tend to sit on hardware for a really long time. So whenever I get hardware, it's gonna last me like 5 to 10 years. So I could absolutely see going to something like this. Toss, 64 gigs of RAM on there, and look at that. L3 cache, 64 megs. Oh my goodness! Yeah, it is good to see competition, especially in that space. They really need it. It just sucks that like when stuff goes poorly, like everything that's happening with Intel at the moment, like if that, it's so hard to turn ships like that, right? It's just so hard to do that. Alright. Cooler not included. I've never used a CPU with liquid cooling. Never seen that. Anyhow, back to the code. Alright, so we're going to follow some little tutorial on benchmarking real quick. Let's just create a little file, make sure benches. Wait, is it supposed to be source benches? No, just benches. Okay. Yeah, my benchmark.rs, whatever. We're just going to toss this in here for a moment. I want to see it run. You can get a really good traditional cooler, and it's fine unless you overclock. Oh well. Yeah, I don't have any intention of overclocking that stuff. Alright, so we'll save that. Can't open file for writing, no such file or directory. Mentions! Oh my goodness. Ta-da! There we go. To make for great CPUs of building something very network heavy. Need to type out a message to my wife real quick. Alright. Alright. There we go, there's that. And now how do we actually run this? Now we just run cargo bench. Oh, I think I missed something. I didn't add that to my cargo file. Cargo bench. Oh, okay. That's going to build some stuff. What do we expect out of this? Goals. Statistically rigorous tool for measuring the performance of code. Oh, that's nice. All right. So, what would we benchmark in here? It looks like we have to have some sort of bench function. Going to do something. It's going to iterate over and over and over again. So we could see what would be a good benchmark for this, though. All right. So we could, let's see, what is our concern? Our concern is that, basically we want to know how long it takes to send or receive, goodness, a whole bunch of messages. I guess in this case it's really sending, right? We're going to set up a whole bunch of channels and maybe send a message or 10 messages to every single one of those channels. It's still going.
Cheers.
I mean, I would like to have the connection server set up eventually. Basically have some, like if somebody's using SSL or whatever, or a WebSocket, whatever this is, I'd like that to be out there, away from the game server. So the game server is not actually spending CPU time shuffling bytes out like that. I'd rather it just dump to the some sort of multiplexed socket, or a socket that's multiplexing stuff. Just dump that out. That'd be much easier on the game server. Wow, this is taking it's taking its sweet time, isn't it? should have done that instead of a buffer so we could actually write some code. But, okay, now what are they doing here? Black box. That's so it doesn't get compiled away, isn't it? Okay. Look at the getting started guide for more details. Alright, so this is a quick walkthrough for adding criterion benchmarks to an existing crate. Assume that it's a crate, my crate. I wonder if this is gonna like be all screwy with like the stream going and all the other encoding. Okay, not so bad. I wonder if there's some sort of setup that we could do instead. Hey, Virvishmat. Good morning. And let me know if I know I butcher everybody's handles on here. Just let me know how you want it said. Adding a benchmark. Okay, group, so we can group them. We can do some stuff like that. Creating a benchmark. All the contents. Okay. Run a benchmark. We did that. Details. Black box. Okay, we also import blast. Describe that later. Declare my crate as an external crate for importing the create a function that contains our benchmark code. Doesn't matter what the name of the function is, it should be clear and understandable. Okay. Bench function method defines a benchmark with a name and a closure. I don't really feel like reading through all this right now. You wrote it phonetically. You're a Vishmat. Alright. Nice. Migrating from libtest. Basically, I want something that we can set up first. I don't want to include like setup time in this. Command line output, warm up, collecting samples, time, change, okay. Detecting outliers, additional okay, notes of caution. Alright, well, let's just create some benchmarks then. Broadcast channels. Oh, can we do this where it's async? Probably. Well, that's gonna be weird. Alright, 20, that's fine. Let's create another function. Nope, not there. Sure, use 74. We're gonna one-up them there. I don't know. This doesn't really have to return anything. Now in this case, we're also going to import small. Is it 4 dash dash? Is there a bench? There's not. It's for dev, isn't it? Okay. So we could do this in a kind of single-threaded way. We could do this in a multi-threaded way. Multi probably makes the most sense, as it would be similar to how this would actually work. we would need a whole bunch of channels. Oh, sure. And thank you for that feedback. I don't get the feedback I need very often on that. Let me check on something real quick. 'Cause I wasn't sure. And this morning I changed something. Testing, is that better? Now I don't know if I actually turned it down. Well, I messed with something this morning because I added this new starting soon thing. Like I added this guy right here, right? And oh, now I'm really quiet. Testing, testing. Hello, hello. Oh, I see. I seem to be quieter now. Hold on a sec. We'll fix this. Okay, now they're both quiet. Huh. Oh shoot. Testing, 1, 2. Hey, there we go. All right. Mic check, mic check. Yay! All right. All right, and hopefully the music's lower because I think that I had actually added a second input for the music and it was a little higher than normal. But thank you for pointing that out. I have a really hard time gauging the balance on that. I didn't test it this morning. So thank you for the feedback. All right. So in this case, let's see, we're going to need a couple more pieces. Let's mimic this. So we're going to need some sort of dash map, right? Or a slab. Oh, I guess we could use slab for this. So we basically want to send a bunch of things over a bunch of channels, right? So we're going to spawn a whole bunch of tasks with channels attached, and we need to store the RX side of it, or the TX side. And to be close to that, we're going to cargo add sharded slab to this. Okay, and I just wanted to build. We're going to put that in the NeoMux terminal, or NeoVim, NeoMux. Oh my goodness. Okay, well, we come back over here. I guess we could do a V-split on that. While it's chewing away. All right, so channels. What else? Slab. Send messages to random channels. I don't really feel like testing rand, so maybe we'll just send messages to all channels. Probably via some just from 0 to n, whatever that is there. Let's rename that to channels, channel count. We'll have message count. Okay. Now in this case, well, let's keep it simple for now. Some really light load. Black box, 20 messages to 20 channels, right? So whenever we create a channel, let's see, channel ID is going to be in channel ID in channel count. Good. Oh, and which one are we going to benchmark this time? Broadcast, async, channel. Okay. Let's put that in the function use async channel. Now these are probably going to be bounded because if it's not actually consuming the data fast enough, I don't want it to just fill up memory. We'll say that we can do 128 messages as a buffer. We tend to have pretty small messages. Oh, use async channel as channel. Okay, type annotations needed. We'll get there. We're going to need to spawn a small task here. Small spawn. Was it async move or is it move async? It's move async, isn't it? Wow, it's a sexy color scheme. Huh. Never thought of it that way. I find it aesthetically pleasing. Now in this case, we're going to loop while let. We'll await that. And we currently do nothing with it. What if there's a way to... we just drop it? Spawn is not found in small. Did we add small? We did. I don't know if anybody knows about the little shortcut. Basically, if you go to open a new tab and you hit %, it'll search your current tab list for the text. So in that case, I looked for small, and then I can just switch to that tab directly. In fact, I think we want this one. Let's see, where's our modules? Functions. You don't like Firefox? It's slow? That's fine. There's only so many browsers out there, and most of them are Chrome now. Chromium. Yeah, Quantum has actually changed it. It's quite nice. Now, I think I have to set this up ahead of time, don't I? Or will run automatically do that for me? So if I call run, thread local and a multi-threaded executor, and then runs the feature. The number of respond threads matches the number of logical CPUs on the core. Okay. Where's detach? I know. I think it's off of task. Okay, yeah, it's off of task. You don't like the community on Bugzilla. Oh. I was also very not sure about. Well, actually, that's a good question. Where is the Firefox community? All right, so we want to do a task spawn. Okay, so we can run an executor. I see. So we have to do this whole thing inside of some executor. That's fine. Let's just do that. Small run. I don't really feel like doing it the other way. Just do that. Async block. Toss that on there. Now, how long? It's going to run that until it finishes. No, we have to do a block on, don't we? Because otherwise, it doesn't block on that. Small, block on. Okay, good. Because we want the timing to be correct on this. I don't know, I've never really had any issues with the current builds. It's fine not to like something. That's fine. Their dev tools have gotten better recently. I have to admit that. It's not, their dev tools still aren't as good as the Chrome dev tools, though. Well, it's alright. Yeah, browser's a browser. I actually think the browsers do too much. I think they've jumped the shark, so to speak. Everybody understand that reference? It's usually in reference to like TV shows. Right? It's that point at where a TV show starts to go downhill. And I think all browsers have actually jumped the shark recently. There was a great post by, was it Drew DeVoe? No, not this guy. The source of the guy. If I can find a list to his blog, he's got some pretty neat stuff. Here. Actually, I wanted it. By Drew. Does he not ever link to his stuff? Maybe under hire free software devs? Ah, here's his blog. It's probably not on the first page anymore, but basically, he goes on to talk about how browsers have become like all-encompassing, and it's not possible to implement a browser from scratch anymore. Wow, he's a little bit of a prolific blogger, isn't he? Not too often, but you know, a couple times a month probably. But yeah, somewhere in there he goes on to talk about that. Oh, is it page 2? Oh, thank you. iOS. Oh, I'm on 3. Okay, there's 2. Oh yes, reckless infinite scope of web browsers. As a web developer and somebody that's been watching browsers for a very long time, and have been working to build websites for browsers for a very, very, very long time. This is just spot on. And I think that browsers have jumped the shark. They have gone past their useful sort of limits. I think that they're actually stepping into territory though, which would be better served by applications. Yeah, people always want more. They basically want applications. And I think things like the iPhone and Android, they're able to give you applications, but there isn't the same sort of experience for the desktop. So, but it's a good one. I actually tried to implement websites with just like HTML and CSS with very, very, very little JavaScript, because I think that they're nice when they load fast, and it only takes like 3 to 4 kilobytes of information to render a web page. There's no need for me to download a megabyte to see like half a blog post. And for the jump the shark reference, it's a reference to Happy Days when the Fonz was on water skis and jumped a shark. Okay. So basically, it's an idiom used to describe the moment when something that was once wildly popular, but has since grown less popular, makes a misguided attempt at generating publicity that instead only serves to highlight its irreverence. I mean, it's not quite not quite the same. It's not like browsers are like creating this publicity stunt or something like that. But it also kind of outlines the life of it, because at that point it kind of went downhill. It's kind of the yeah, it is similar to past its peak, but more specifically suggests an unwillingness to acknowledge the fact. uh, yeah, I think that browsers are becoming, um, I think they're treading towards that. Yeah, I don't think it's long before people get tired of, 2 to 3 megabyte web pages and just want something else. Can you see the game? There is a clip on there somewhere where you can actually see it. It doesn't run at the moment though. All right, but we were going to benchmark this. So we do small, we block on that. For each one of these channels, we're going to do a task, small task. Is it a capital T? Small task spawn. I'm going to move that to the beginning of the list there. There we go. Where's task? Task. Yeah, you just give it something and then you have a task and you can detach it. Great. And it is spawn, right? Yeah, spawn with the future and we detach it. Lovely. Interesting. No next found on that. Is it receive? There we go. And that'll be an option. Okay. What should we send? I think we could just send numbers. We could send strings. I mean, arguably, it's just going to be probably some bytes that we're sending across. Let's use bytes. We'll just come up with some set of bytes. Oh, you're interested in compiling Chromium, but it looks complicated. It's not that complicated. I've actually done it in a couple places I've had to work. It just takes a while, right? Like you can recompile BSD faster than you can compile Chromium, like world included. Okay. And we're just going to be dropping those, so that's fine. Our channel, we've got our channel ID, that's unused. Now we need to start saving those channel IDs into the slab along with the RX. So where's our slab? Just a new slab. Oh, it's a sharded slab. Yep, you don't know the type yet, that's fine. Did insert. And what are we going to insert here? This will be... Because we don't need the channel ID in this case, do we? So technically, this will give us some sort of number back. We'll have to keep track of that. Huh. We're just going to save that in a vector for now. Let's save the RX, the TX. RX used already. There's the channel ID. It should be a U size. We'll just unwrap that. We don't care if it bails in this benchmark. Channel IDs dot push. And just for fun, let's make sure that we allocate this with capacity being the channel count. There we go. So we push all of those in there. We start tasks that are running that. Oh, found that. Expected that. I don't care enough. Okay. There we go. So now we've got our receivers, we've got our channels. Now at this point we could get them back out of the slab and start doing stuff with them. Let's see, should we set up a couple more tasks to do that? Or just iterate like one over the next? Let's keep it simple at first, and we might set up another task to do this. Let's see. For underscore in we'll just iterate through and send a message to each and every channel. Arguably, this would go better if you know what? We could do that the same way as we did before. We can use the futures unordered with a whole bunch of async tasks to send this out. And I think that would be a fairly good approximation of how this would work. Oh, this would be strange though, because what do we expect our window size to be on this? We might actually be able to use window here. No way. Probably not. Okay. I was thinking through it. Window. I know. I so want to use window. Right. It brought you out a lurking set because we could actually try to use window here. It makes me wonder how many actual messages would we end up sending though, because window slides across a number of values. If you had something here, right? So if you had a whole bunch of values in an array, window. Let's say our window was like 10, right? First it would be here, and then it would move over one place. So it's not like it chunks it. I think chunk is more what we're looking for in this case, because we don't want that just sliding across. But we could though. Huh. Having to think through that. That's interesting. So we'd have to calculate how many messages were being sent then, because it would be kind of a function of the window size across the channel count size. All right, okay, let's just keep it simple. I want to get this done. So in message count. All right, we're going to send this many messages in that. There we go. Then we have a static message. Let data is equal, or message. It's just going to be an empty bytes. I don't really care how big that is at the moment. We're just going to be dropping the copy of it on the other side. So this is like a atomic ref counted value. It's very similar to, I guess, clone on write, but there's a bit of a magic backbone behind bytes. And then for every single one of those, I want to send them all at the same time though. I don't think I want to create that many, spawn that many tasks. We could. Because ideally you're going to be sending buckets of bytes to a handful of people at a time. The people are generally going to be clustered. Window was so close. So close. Can we do chunk? Yeah, we can. They're slices and they do not overlap if chunk size does not divide the length. Okay. Okay. Let's just send messages for a moment. Channel IDs dot iter dot for each. We'll get that out of the slab. What's our slab? Slabs on channels. Channels dot get ID dot send message dot copy. Do we have to wait on that? Oh. We expect that to be in there. We're gonna unwrap that. Are these are async channels. We can just try send. Try send that. Oh, it should be clone. My mistake. Hey, good morning. Is this some sort of networking that is being worked on? It is. We're benchmarking some ideas for sending packets out to a large number of sockets at the same time. right, does that build? Looks like it builds. Channel ID is unused. True. Just get rid of that. This is going to be the server code. Performance has regressed. No. Yeah. That's since our last run, though. So what is that actually saying? That's saying that it took 4 milliseconds to set that up and run all of that, which is fine. I mean, we didn't put many things in there to begin with. All right. Let's send a lot more messages. Uh, 2,000. And how many of these? Let's see, 1,000. Let's say that there's 10,000 players. We're sending 200 messages to each one of them. I wonder if this is actually going to be linear. Because we're only doing, this send is only happening one at a time. But I'm going to have to get going shortly. Oh, it panicked. Really? Oh, it was full. Line 3717. Channel ID is iter. Oh, I see. It didn't get enqueued because the task didn't get serviced. I see. But if we did that with an await on it, that'd be different. Am I running off of one thread? No, this should be multi-threaded. Are we not in an async block? We are in an async block. Oh, but here... Oh, come on. Channel ITs. What's moved? Oh, wrong way. Results not being used. And am I okay with that? I am. What's cracking? Erikar, welcome. We're actually working on a little bit of benchmarking because we're trying to figure out how long it would take to send out a certain number of packets to a large number of players. So imagine on the server, you have, let's say, 20,000 players connected, right? And would it be feasible to have a channel, like an async channel, set up for each and every one of those? Oh, 100 iterations per minute. Wow. That's quite a few packets. So what does that come out to in terms of this? This is I forget, did we say 20,000? Oh, 200 packets, and was it 20,000 players or 2,000 players? Anyhow, basically what we're trying to do is establish some sort of baseline or idea of whether or not this would be a feasible way of sending out packets. Now this says it takes half a second to send out 200 messages to 10,000 channels. Interesting. Hold on. All right. Well, that's fun. Okay, I think we might play around a little bit more with this next time, but I've got to get going. All right, do you have any BSD fans out there? Yeah, I was actually if we've got anybody interested, so there are often things like the ports, right? And people maintain these, right? Currently there's 32,619 ports. And one of the people that I follow is did I one or two L's? I forget. So just one? SWILLS6. Oh, one too many eyes. And this guy here, man, he works on a lot of the BSD stuff. So random BSD ports hacking. Oops. All right. But it's fascinating watching how somebody actually maintains that. Committing changes from community submissions. So when somebody does something in the community and it has to be modified or changed a little bit in order to work on FreeBSD, maybe it's a Linux sort of piece of software that ends up coming across. Like it's people like that, like this guy, actually make all that happen. I think it's fantastic.
Look, you and me on the Charles River. Could die right now, Glenn. I'm just happy.
This guy's been doing it for 10 years.
Never felt that before.
Yeah, 10 years. So I'm going to give him a raid. You know what's incoming. So follow us if you will. If you want to see how the process is. I'm sure that there's the same sort of thing for Linuxes and other BSDs and stuff like that. And these guys are just kind of tireless. It's amazing. And I absolutely appreciate it. So I'm going to give him a raid. I know it's not Rust, but this is the other end of the software community. You write some port, you write some library that gets useful. This guy puts it on all the other operating systems. Gets it to compile. All right, y'all. Thank you. Until next time. Bye-bye.